Hey guys, welcome to Inspire Chemistry, and today we are doing salt analysis. So as you know, salt analysis is a very important topic even in practicals of 11th, 12th, and it's an important topic in your JEE mains, JEE advanced, and it can be a helpful topic when it comes to high competition in case of IIT Jam Chemistry. So let's start the video. So today we are doing salt analysis. So as you know that what is salt analysis, right? So salt analysis is you have like NaCl. It is made out of two ions, Na plus and Cl minus. So the two ions belong to either a acidic radical or a basic radical. What do you mean by acidic radical? In case of NaCl, Cl minus comes from acid HCl. Sodium Na plus comes from NaOH, which is a base. So these two actually comprise to make a salt. Okay. So what is actually salt analysis? So salt analysis, you can see it's a technique where in order to find which salt is provided to you. Like in the examination, if I'm a teacher, I'll give you some salt and I'll ask you to find the composition and the type of salt. Like if it's NaCl, BaCl, what salt it is. So as of now, there's no specific scheme how to do it, but there have been some tries from scientists how to comprise this to make a scheduled way to find out the radicals, the acid radicals and the basic radicals. So the first question is that people like this question might come in your viva. Why do we go for acidic radical first and not basic radical? The reason being there are some acidic radicals like borate, fluoride, phosphates, etc., which actually interferes when you go for basic radical detection. So in order to avoid that, we do the acidic radical detection first and then the basic radical. So in this video, we are going to look at the acidic radical detection, and especially for the volatile compound. So in general, there are two types of tests, the wet test and the dry test. So dry test, you must have heard that there's borax bead test, charcoal cavity test, and flame test for barium, calcium and all. And other test is called the wet test, where you do the reaction in solution, some kind of solution. Okay, so those are wet tests. So today we'll do the acidic radical part. So the first thing if you're given a salt, you take a pinch of salt in test tube, then you add acid to it. Acid, as you can know, are usually of two types: the dilute acid and the concentrated acid. So dilute acid and concentrated acid, usually the most used acids are H2SO4, HCl, and sometimes people also use acetic acid. But acetic acid is generally a weak acid, and it really doesn't depend if it's really dilute or it's concentrated. Correct. Now, when you have a pinch of salt in your test tube, you add first the dilute acid. If it doesn't yield you anything, then you go for concentrated acid. So if you add acid to your compound, there's again two possibility of two things. This can yield you a volatile product, or this can yield you a non-volatile product, right? So in volatile product, what you do is you add a dilute acid to your compound. If it gives a volatile product, it can be these acid radicals. What are these? These are carbonate, CO3 minus 2, bicarbonate, SCO3 minus, SO3 minus 2, sulfide, SO3 minus, bisulfide, thiosulfate, S2O3 minus 2, and this is S minus 2 is sulfide, and this is acetic radical because it comes from acetic acid, and this is nitrite radical. Okay, and if you don't yield anything out of after adding dilute acid, then you need to add a concentrated acid to this mixture. Okay, So now when you add concentrated acid, this, if it yields a volatile product, this can be due to these radicals, Cl minus, Br minus, I minus, NO3 minus, and this is carboxylate minus, C2O4 minus 2. Okay, so or if you add acid, nothing volatile comes in, like you added dilute acid, you added concentrated acid, but it is not yielding you anything, then this could be actually a reason of due to non-volatile product formation. There can be sometimes PPT, precipitate formation, PPT formation, which can be due to fluoride minus, sulfate minus, borate and phosphate. And there can be some redox reaction in your mixture, might be having redox reaction in the mixture, which can be due to some transition metal compounds like MnO4 minus, CrO4 minus, Cr2O7 minus 2, but these are usually not asked. And it's the most important ones are these ones for JAM and all the exams, because these D-transition metals are form an important compounds when it comes to redox chemistry, and that you will read in D block elements, and even if the question comes from here, it will be related to D block, not the salt analysis. Okay, so what is the chemistry behind this? So for the chemistry, you might be wondering why I wrote this in a like in a coupled form, by carbol CO3 with SCO3 and sulfide with bisulfide. So the reason being this thing. Now I'll be telling you what all gases are evolved out of it. So dilute, now it's a here I have written the chemistry behind volatile. If you add acid to your mixture, you get a volatile product on addition of dilute acid. So if you add acid and you had this CO3 minus and SCO3 minus 2 radical in your system, this will give you a CO2, which is carbon dioxide. And as we all know, carbon dioxide gives a brisk effervescence. And C, if I write C cross, that means it doesn't have a color. It's a colorless gas. C cross means it's a colorless gas. It's a odorless gas, right? Then you can have a sulfide, bisulfide and thiosulfate. And if you add dilute acid to it, and you might be there's sometimes there might be need of heating a bit over Bunsen burner or something, and it's the heating is required usually in case of thiosulfate, and you'll have a SO2 gas coming out. Again, this is a colorless gas, but you can actually find it out that it is SO2 because it has a suffocating odor. You'll feel suffocation of a burning sulfur, right? So this can be due to SO2. Now the next, if you had the sulfide radical in your system, if you add acid to it, you'll get a H2s gas. So it's a colorless gas, and you must have heard this term, rotten egg-like smell. This is the gas which is responsible for this rotten egg-like smell, H2s. And this is a very important Viva question as well in your class 11th and 12th practicals. And if you go for if you had NO2 minus nitrite in your system, if you added dilute acid to it, I've written H plus all along the way, and this will give you NO2 gas, and it's not a colorless gas, it's a brown color gas. So it gives you an advantage to actually find out that it can be due to nitrate NO2 gas and not due to other gases. So please, I've put a star here so that you can recognize that it is more important. Then there can be some acidic radicals in your acidic anion in your system. If you add dilute acid to it, it will form a clearly acetic acid. If you add acid to this CH3CO minus, it will go on to form a acetic acid, which is a vinegar smell, because vinegar, what is vinegar? Vinegar is actually a very diluted form of acetic acid. So that's all for the dilute acid part. If I continue, if you get a volatile product after addition of a concentrated acid, so we'll be talking about this. So as you can see, if you had a Cl minus in your system, you add concentrated HCl, what you will have is HCl, right? And you can see that if you add acid to concentrated acid to the mixture and give if it had been containing Br minus along the way, you get a Br2 gas. But in HCl you get In Cl minus you get HCl, and in Br minus you get Br2. So make note of that. And HCl is actually a colorless gas, but it has a pungent odor. Like you'll start feeling a pungent odor in your nose and mouth. So HCl gives you a pungent odor. Br minus, if you had in your compound, if you add concentrated acid to it, it will yield you a Br2 gas, which is again a brown colored gas. And as you can see, when you added dilute acid to this mixture, NO2 gas, if it was there, that was also brown colored gas. So there can be a brown colored gas, and if you want a pre-conformation test for Br minus radical, you can add a MnO2 to this solution, and this will increase the intensity of fume increases with MnO2. So there will be the more fumes coming out of the your test tube, and that this could be due to Br minus radical. Next comes the I minus radical. If you add acid to it, it will form iodine. Iodine gas, which is violet gas, and addition of MnO2 will give you a condensed black colored substance, I2. Okay, it will give you a black colored substance that this is actually a pre-conformation test for I minus, right? Then you have a nitrate ion. If you add concentrated acid to it, it will give you NO3 gas, and this gas is again a brown colored gas. Okay, which makes again NO3 important radical. And in order to distinguish between Br minus and NO3 minus, if you add MnO2 to this, intensity will not increase in case of NO3, but intensity of fume increases with MnO2 in case of Br minus radical. Correct. Then comes the last C2O4 minus 2. If you add concentrated acid to this mixture, you'll have a carbon monoxide, CO2, and other gases might be there. So this again it burns with a blue flame that tells that it is actually due to some C2O4 minus, because it's really good in combustion. So that's all for today's acidic radical video, and we'll bring you another video where you'll find the rest part which is left in acidic radical, and this is actually the very first step in the salt analysis, and we'll bring you more videos upon this, because I've seen videos on YouTube which really doesn't cover this topic in detail, and they just tells you some questions that are important, few answers, and if it comes to JAM, you can actually score like extra 4 or 6 marks even if you read this topic once before the examination on the same day, and this will make you stand out of the other crowd who usually doesn't read or pay attention to these minor topics, because in 2019 it came for around 4 marks, and it was not a direct question. So those who learned just direct how to, if this color belongs to this color belongs to this, they might not be able to do that question, but I'll make videos on that, so that you'll also be able to do those questions. And that's all for today. And if you like this video, please hit a like button, share with your friends, because so that they can also go through these videos which are really important. Please give us a subscribe in order to encourage us to make more videos. And that's all for today. Thank you.